Welcome back. The objectives of this video are to introduce horizontal translations and vertical translations of the sine and cosine graphs. We're also going to do an example of how to find an equation based on the graph. So let's take a look at our first objective here, and we're going to look at the sine and cosine curves. So we have y equals a sine of bx minus c. So this whole bx minus c is a little bit different than what we've seen before. A is still going to be our amplitude, so that's not going to change things. So whether it's sine or cosine, A is still going to be the amplitude. And B, that's going to impact the period. It's not our period, but it impacts the period. We use that in calculating the period, 2 pi over B. And our phase shift is going to be C over B. Okay? So both of these graphs will complete one period from bx minus c equals 0 to bx minus c equals 2 pi. So we're going to use this bx minus c here, and essentially we're going to pick up our graph and we're going to move it horizontally left or right based on that bx minus c. So think of just picking it up and shifting it to the left, or picking it up and shifting it to the right. And that's how that bx minus c is going to impact our sine and cosine curves. So we'll walk you through an example here. Let's sketch y equals 1/2 sine of x minus pi over 3. So our c here is pi over 3. It appears that b is equal to 1. It's the coefficient on x. And our a is 1/2. So our amplitude is 1/2. So now we're only going to go half as high. Our period is 2 pi over b, or 2 pi over 1. So that's still going to be 2 pi. And here's part of the new stuff. We're going to calculate our interval. So we're going to take that bx minus c equals 0 and bx minus c equals to 2 pi. And let's see what happens to our interval here. So we're going to just add pi over 3 to both sides. So we get x equals pi over 3. And x equals 2 pi plus pi over 3. So that would be essentially 6 pi over 3 plus pi over 3. So x equals 7 pi over 3. So our graph now is going to move from pi over 3 to 7 pi over 3. And our period, though, is still 2 pi. So we're going to this is still 6 pi over 3 in between. So we still have a period of 2 pi, but we have now shifted this whole graph pi over 3 units to the right. So I've got some notes here. We're going to take a look and find out what our intercepts are, our maximum, another intercept, a minimum, and another intercept. So these are going to be our 5 critical points of our sine curve. And then what we need to do, though, is we need to figure out our scale, or how we're going to count along the x-axis. So we're still going to divide this into 4 equal parts. So if our period is 2 pi, and we want to divide that by 4, we're still going to count, right? Divided by 4. So we're going to still count by pi over 2, or if you will, we'll count by 3 pi over 6s. So since we're going to start at pi over 3, this is kind of our new origin. It's our new starting point. Pi over 3, which is also 2 pi over 6. So when we're going to count by 3 pi over 6s, that means our next point is going to occur at 5 pi over 6. And then another pi over 2, or 3 pi over 6, is going to be 8 pi over 6. So you might want to reduce that to 4 pi over 3. And then our final spot is going to be another 3 pi over 6. That's not our final spot, I beg your pardon. It's 11 pi over 6. And our final spot is going to be out here at 14 pi over 6. So we're going to have our 5 critical points dividing our curve into equal fourths. So if we've got our sine curve memorized, we can kind of figure this out. I'm going to change my scale here where these are going to be halves. So negative 1/2 and 1. So the sine of pi over 3, our starting point of our sine curve, has always been 0. So that's going to say 0. So that's one of our intercepts. Our intercept is going to start at pi over 3, 0. And then at 5 pi over 6, or our next point, since our amplitude is 1/2, we're only going to go to 1/2. And then our next point at 8 pi over 6, we have another intercept at 0. So we have a maximum here. I might as well put that in right away. 5 pi over 6 and 1/2. Then we have another intercept at 8 pi over 3, or pardon me, 8 pi over 6, or 4 pi over 3, 0. And then we're going to have a minimum, probably down here somewhere. And that minimum point is going to be 11 pi over 6 and at negative 1/2. And then it's going to swing back to 0 again. So we have another intercept at 7 pi over 3, or 14 pi over 6, 0. And we draw our sine curve and connect all those points. So all we did is we shifted our graph over pi over 3. That x minus 3 turned out to be a right shift of pi over 3. Very similar to what we saw in graphing quadratics, where we had x minus h, and that shifted, that minus h shifted our parabola in complete the square form to the right or to the left. This is the very same concept. Let's do another sample, something that's a little bit more complicated. We're going to graph a cosine curve now. So we're not going to have 3 intercepts and a max and 1 max and 1 min. We can talk about those, but we are going to definitely split this up into those 5 critical points again. So let's take a look at what we have. Our amplitude here, our a equals negative 3, so we're going to have an amplitude of negative 3. That's interesting, having that as a negative. Our period, looks like our b value is 2 pi. So our period is going to be 2 pi over 2 pi, or 1. So we have a period of 1. Interesting. And then finally, let's calculate the interval. Let's take 2 pi x plus 4 pi and set it equal to 0. And 2 pi x plus 4 pi and set it equal to 2 pi. Normally we have 0 to 2 pi. So we're going to see how all of this impacts things for us. So we subtract 4 pi from both sides, and we get 2 pi x equals negative 4 pi, and divide by 2 pi. And we get x equals negative 4 pi over 2 pi, and we get an x of negative 2. So that's going to be the minimum of our interval. And let's see what the maximum is along the horizontal axis. again, we're going to subtract 4 pi. So we get 2 pi x equals negative 2 pi, because I subtracted 4 pi from both sides. When I divide by 2 pi, I get x equals negative 1. So our curve is all going to occur here for one period between negative 2 and negative 1. So we're going to divide that 1 by 4, so we're just going to count by 1/4. Probably should put that note somewhere else. So we'll count by 1/4 between negative 2 and negative 1. So negative 2 minus 1/4 is what? Negative 7/4. And halfway here would be negative 3/2 or negative 6/4. And again, here we're going to have negative 5/4, and negative 1, of course, is negative 4/4. So negative 8/4, negative 7/4, negative 6/4, negative 5/4, negative 4/4. So we've got our critical points, so we can walk our way around the cosine curve. Now you may recall that our cosine curve, when the cosine was 0, cosine of 0 radians was 1. But our amplitude is negative 3. So now the cosine of our new origin of negative 2 is way down here at negative 3. So if I put x in for negative 2 here, y equals negative 3 cosine of 2 pi times negative 2 plus 4 pi. All of this is going to become 1 and then times negative 3. So I'm down here at negative 3. So we've really flipped it. Normally it would be 1 or negative 1, but now it's negative 3. And then follow the process for our cosine curve. Our first period would always be 0. So that works out well. So our first point, I might as well plot that, was negative 2, negative 3. That was a minimum value. And then we had an intercept here at negative 7/4, 0. So that's an intercept. And then we're going to have our next one is going to be a maximum, isn't it? So at negative 3/2, now we're going to be all the way up at 3. So at negative 3/2, we get a positive 3. That was normally negative 1, but we're reflecting this. And then we have another intercept at negative 5/4, 0. So we're coming back down. And then we have another point, negative 1, and that's going to be down at negative 3. So we're back at another minimum again. And that one was a max. So connecting our points for one period for the cosine curve, it's going to look something like that. And now that will continue to repeat, won't it? But what we have done is we've taken our cosine curve and we've shifted it over. We've adjusted our period as well, and we've flipped it upside down, and we've increased the amplitude. So lots of stuff going on in that particular curve. We can also do a vertical translation. So the 3 is our A, the 2 is our B. That's going to impact our period. But this 2 here, this is going to create a vertical shift. So this is going to be a vertical translation or a vertical shift. So again, like our quadratics, when we had a times x minus h quantity squared plus k, Now we're working with the plus k. The A was our amplitude, the H was our shift left and right, but now we're going to do a vertical shift up or down, and that's what that 2 is. So our amplitude here is 3. Our period is 2 pi over b, or 2 pi over 2, which is pi. And now we want to calculate our interval. So it's 2x plus 0 is really that bx minus c. So 2x plus 0 equals 0, and 2x plus 0 equals 2 pi. So 2x equals 0, we get x equals 0, and we get 2x equals 2 pi. So we get 2 pi divided by 2, and x equals pi. So our interval is between 0 and pi, and our period is pi. That's kind of handy. We've got an amplitude of 3 and a vertical shift of 2. Now we're graphing the cosine curve. So we're going to start at 0, and we're going to count by pi over 4s. We're just going to split this into 4 equal parts. So count by pi over 4s. So we have, we can go all the way out to pi. Halfway will be pi over 2. So pi over 4 and 3 pi over 4 on our x-axis. And it looks like we're going to count by 1s here. So if we put 0 in for x, that was normally 1, wasn't it? Okay, it was normally 1, but now we have an amplitude of 3, so that's going to move us up to 3. But then we're adding 2 to that, so it moves us all the way up to 5. So our first ordered pair here, our first point, is 0, 5. And then on the unit circle, or on the regular cosine curve, pi over 4 was normally 0. Our first one was normally 0. 3 times 0 is 0, but we're adding 2. So our next point here is at 2. And then at pi over 2, you'd think with a magnitude we'd go down to -3, but we don't. We only go down to -1. And at 3 pi over 4, that's going to be a reflection. And at pi, we're going to be back up at 5. So we've taken this graph with a magnitude of 3 and we've shifted it up 2 units. So our minimum now is -1 instead of -3, and our maximum is up at 5. And we really don't have any intercepts here that we're going to calculate. There are intercepts, of course, but we are not going to figure out what those are. So I don't really care about that per se, but our particular ordered pairs, pi over 4, 2, pi over 2, -1, that happens to be a minimum. And our final point was, I'm missing one, 3 pi over 4 was 2, and then our final point was pi and 5, so we're back at the maximum again, and our cycle is going to repeat. Sample 4, find the amplitude, period, and in phase shift of the function whose graph is shown. Write the equation of this graph in terms of a sine function. So let's take a look at this graph. This is a sine function. It looks like we've got a minimum down here at 2 and a maximum of 2. So it appears that, well, we're going to start, this is a sine curve. And I see, right off the bat, I see an amplitude of 2. So instead of 1 high, we're going 2 high. And what I see is a shift to the right of pi over 2. What we don't see here, what's not shown, is this curve is going to continue like this. And we have essentially our sine curve is tucked in here between pi over 2 and 2 pi. I think I may have mislabeled that, but I guess that would be 5 pi over 2. So that's kind of where our curve is. So we have done a shift to the right of pi over 2 units. And our interval is still 2 pi. Or our period is 2 pi. That hasn't changed. And I saw that from negative pi over 2 to 3 pi over 2. I knew that was an entire cycle. So that is a period of 2 pi, which means our b value is 1. So let's take a look at this. This would have to be y equals an amplitude of 2 sine of x. Since we shifted right, it's going to be minus pi over 2. So that looks like the correct answer. Some of you may have seen, I saw a sine curve here between negative pi over 2. I saw actually two things. I saw, when I first did this, I saw a shift to the left, but then I also saw a flip. So we could have looked at this as y equals the opposite of 2 sine of, and now instead of shifting to the right, we shifted to the left, so it'd be x plus pi over 2. So that would be another correct answer. Let's take a look at our graphing calculator. Let's just graph y equals 2 sine of x, which I think I already have graphed here. So there is our sine curve. I'm going to extend that out to 5 pi over 2. Note here, in order for this to work, your calculator must be in radian mode because we are working in radians. So there's our curve. That's the regular sine curve. And then we thought that we had shifted this. So let's go ahead and graph our answer. We had 2 sine of x minus pi over 2 as our answer. And let's see if that mimics of what we had. And that would be the blue curve here. And sure enough, that's exactly what we had in our notes. That's that curve. So we got that one right. But let's see what happens when we graph our second one. We had possibly shifting it upside down. We flipped our amplitude and then shifted it to the left. Let's see how that one looks. So we'll graph that one right on top of it, hopefully. So this one looks like it's going to be a black curve. And look at that. That black curve goes right over the blue curve there. So we got that one right. That's the exact same thing. And now it didn't ask for this, but we could also graph this in terms of a cosine curve. And this is the cosine curve of y equals 2 cosine of x minus pi. So think of this as taking the cosine curve and shifting it pi units to the right. So remember, our cosine curve starts at 1. Now this one starts at 2 because we have our amplitude is 2. But if that is pi, we have shifted this pi units to the right, so our cosine curve would start here. So putting that into our calculator, now that one's going to be like a magenta color, and hopefully it'll graph right over the black one. And sure enough, it's also the exact same thing as our cosine curve. So multiple correct answers to that question. We couldn't use the y equals 2 times the cosine of x minus pi here, okay, because they asked for it in terms of sine. So either one of these two sine curves would be a correct answer for that. And we'll get some more practice with these kinds of problems when I see you in class.